Alright, so guys, we are now recording. And I'm going to put on my mic so you can hear me better. And the recording can hear me better. And so if we look at this, the first one, and I heard some good explanations of this problem when I was walking around. Someone even said, if 30% are on sale, what percent has to be not on sale? 70%. So we would do this 660 times the 0.7. So 0, 42, carry your 4, 46. 462. Okay? 462.
Books are
All right. The next one. How many of you looked at it and went, ooh, if x were 1, that would work?
Yeah.
Because 1 plus 1 is 2. Yeah, x is 1. So that made this problem really easy. Okay? Because here we get 1 plus 1 over 1. So 1 plus 1 is still 2. But what if it were equal to any other number besides 2? And we couldn't just look at it and tell what the answer was. Then this would be our approach. And SAT does this also. Where if you square this and square that, if I square this, doesn't that mean write it out twice? Okay. Now, a cool thing's going to happen in the middle. I'm going to multiply this times this and get x squared. But then I get x times 1 over x. Then I get another x times 1 over x. And then finally, here and here, I get 1 over x times 1 over x, which is 1 over x squared. Real quick, what happens to these x's and those x's? They cancel. They cancel. And leave us with 1 plus 1. So right here we have a 2, because 1 plus 1 is 2. All right, so we have x plus this thing, 1 over x squared, plus the 2 is equal to 2 squared, which is 4. So if I subtract the 2, I would also get that it equals 2. Now, this one's much easier to look at. But if we have one, like an SAT question towards the end of a section, it's going to be harder. So they're not going to pick a value for x that's really easy, like 1. They'll pick one that you have to solve algebraically. Okay, the last one. To get the shaded, like we want to do the ratio of this inner shaded part to the outer shaded part. And to get the shaded, we're going to have to do some subtraction of circles. Do you see 4 circles? Yes. A small, a medium, a large, and then an extra large? That wasn't extra large, that was double X. Extra large. All right, there we go. So, there are 4 circles there. Now, if I'm trying to find just the shaded part, do you see if I took the biggest circle and took away the inside, it would leave me with the shaded part? If I took the big circle and took away this part, it leaves you with the shaded. Okay, so I touched the screen. So we're going to do the same thing. For the inside one, if I take the medium circle and subtract the small circle, it leaves me with this inside shaded part. Well, the area of the circle is pi r squared. But if you have a brain freeze, which we all do at times, on the SAT, that pi r squared can be found in your formula box. That is one of the formulas they give you on the SAT. So here, we'll do pi times our radius squared. So that's our medium one, because it says the radii go 1, 2, 3, 4. So that medium one has 2. The small, 1. The large, 3. And the extra large radius is 4. So I'm going to do 2 squared pi minus 1 squared pi. 4 minus 1 is 3. Now, to get this, the outside shaded ring, this little part right here, I'm going to do the extra large minus the large. So it's 4 squared pi minus 3 squared pi. 16 pi minus 9 pi is 7 pi. So this asks me to come up with the ratio. It is 3 to 7, which they wrote it in this form, but that's still 3 to 7.
I have a question.
Yes.
On the first question, are there 4 boxes?
They have a gridded response, and you can use up to 4 boxes. You may not need to use all 4. All right. So that is today's warm-up. Now there's some other things we're going to do today. Did you guys pick up the packets when you came in?
Yeah.
You just need the one big packet. So if you didn't grab that, go ahead and grab that. And we're going to talk about a couple things today. The first thing I want to show you is
I just never read them. They have some like
I thought we had to put it in military town. Maybe not. Alright, we will just cut this off and make that too. Alright, today guys what we're going to do is we're going to discover some things about polynomials using Desmos. And I'll put that part back up in just a second. Because when we use the Chromebooks, which we're going to be doing today, I will go into Orchestrate and give you permission just to use the websites we're using. Okay? So we're not going to be using other websites. And I'll leave Orchestrate open. And you guys know that we can see every place you are. Every tab that's open and every place you've been on the Chromebooks.
Like you can track you?
Yes. Yes.
Like if I'm in Alabama,
No, they can't. Okay. They don't know where you are, where your physical body is, but they know every place you've been online.
so yeah, they know.
Okay? So that worked out handy. That helps us all stay a little more focused. And I'll show you that in a little bit. But today we're playing with Desmos. So let's go ahead and pull out those Chromebooks.
I charge mine.
Get it started on
They can see one car of
Alright, once you get them turned on, please go to Desmos.com, and click Start Graphic. Not everyone says like this. So, you can hit the next arrow, and anybody that hasn't finished this taking the quizzes will get a very special different version.
A handwritten version.
I just closed it and shut it. But then you can try to that's nice.
Today, I'm probably going to let you start in class, but I just have to get my time to practice. Alright. Okay, so Desmos is a super cool online graphic calculator. It's actually the one that I use instead of my TA84 most of the time when I'm at home. I don't even take my TI home anymore. I leave it here. The reason is it's extremely user-friendly. So Yes, sir.
I was going to say, is it
We don't need a code for Desmos.
sure?
Yeah, you just click start graphing.
He's only one page.
Oh, just go to you don't go to student. Yeah. Okay. There is another way to log into Desmos. So if I create an activity and I want you to log in with your Google account, there is a different way to log in. So let's pause ahead of the curve over there. He was doing it. He was assuming we were going that way. What we're doing today is we're learning how to discover different characteristics of our graph using Desmos. And your job is to tie things together. The two things you're looking for today are end behavior and root behavior. So what do the ends of your graph do? Do they go up on both ends? So that would be as we go to, if it went up on both ends, as we went to, this way is negative infinity to you guys. Negative infinity, the graph is going up. Positive infinity. If x is going towards positive infinity, the graph is going towards positive infinity. What if it looked like this? This end went up, this end went down. So as x goes to negative infinity, your graph is going up to positive infinity. So that's one of the things we're going to look at, end behavior. What are the ends of your graph doing? Now, when we talk about that, we don't care about the middle. We're not looking at the middle. The middle could have lots of hills and valleys, and we're not looking at those. When we're talking about end behavior, we're specifically looking at the ends. So the example that I have on the board right now, as x approaches negative infinity, so basically, as we go as far left as possible, the graph keeps going down. Do you see that? It's going to negative infinity. And as x goes to positive infinity at this end, what is the graph doing as we go right? It's going to positive infinity. So, one thing you're looking for on all your graphs is end behavior. But you're trying to think about what happened in this equation to cause the ends of the graph to do what they did. What about the equation would make both ends go up? What about the equation would make both ends go down? That's what you're supposed to figure out today. Tomorrow I'm going to check back in with you and make sure you figured it out. All right, the second thing you're going to look at is what happens at the x-axis. On this one, do you see it is passing through the origin? It passes through at 0, 0. So we're going to take this and look at our factors and go, what about the equation caused it to pass through at 0, 0? Versus, look right here at the x-axis. It doesn't pass through. It comes down, it hits it, and it bounces back. And the word that we use for that, where it hits and bounces back, is tangent. So, does it pass through? Is it tangent? That's the other thing you're going to look at. And the final thing you're going to look at is the degree of the function. I have this on the whiteboard over here. My first example is y equals x squared. So it's only one term, and the degree is 2. This function has a degree of 2. What does the degree of the function affect? Now the next one is y equals x squared times x minus 1. To find the degree, when you have multiple factors, you have to add those exponents. 2 plus 1 is 3. This one has a degree of 3. Does that affect the end behavior? And does this 2 and 1 affect what happens at the x-axis? This last example, we have 2 factors, but this one's squared and this one's cubed. So 2 plus 3 gives this one a degree of 5. So today, your job is to work through and even together, talk about it with those people around you. You are welcome to talk if you're talking about math. So you're going to investigate those particular things, and your job is to get through K, parts A through K. If you finish in class, you have no homework. If you do not finish in class, your homework would be to finish just through K. Not the whole packet, through K.
Yo, Freddie.
let's focus. Logan. Logan.